use the graph of y equals f of x to answer the questions that follow. So we have this function. It appears to be piecewise. It's got a straight line section, then a break, then another straight line section, then its behavior suddenly changes to curved, and then it seems to go back to being a straight line here. So this is 4 pieces. This would be a real doozy if they wrote it out, but all we have is the graph, so not that bad, I suppose. And they ask for a bunch of limits. The limit of f of x as x goes to 1. Well, here's x equals 1. What's the function doing there? Trying to go straight up. I'm not doing a great job. Is about there where the function is? If so, that's 1, 2, 2.5, something like that. And we aren't anywhere near one of the transitions where it goes from being one piece to another, so this limit's fairly simple. We just say when x goes to 1, it seems like we get infinitely close to about 2.5. That would be our limit. In other words, if you had 2 people walking along this line, one from the left and one from the right, they'd end up standing toe to toe and both agreeing that, yep, they're right next to the point 2.5. Next, they want the limit of the function as x goes to 2 from the left. Let's get another color here. Okay, so coming at 2 from the left, here's 2. If we're approaching it from the left, we must be up in this section here. This is where we go 1.9, 1.99, 1.999. We seem to be approaching, is that 5? I'd say 5 is our left-hand limit. A person standing right on the edge here would say, yeah, if I crept a little more to the right, I would land on y equals 5. Little do they know, that point is actually far below them at 2, 1, but when you ask for a left-hand limit, this is what you get. You get someone who came in from this direction and they don't have all the information. They only know what's happening as you come up from below. And speaking of which, now they ask about what happens if you come down from above. Number 3 is the limit as x approaches 2 from the right. So now we have a person coming in this way, getting in closer and closer to 2. And their y value, it appears, is approaching 1. And this person is right. The limit really will be 1 when we get to x equals 2. But just looking at the limit, we'd say that the limit is 1. And finally, they ask about the two-sided limit as x approaches 2. Well, if our person coming in from the left says the limit is 5, and coming in from the right we get that the limit is 1, then what's the two-sided limit? Trick question. There isn't one. We'd say it does not exist because these 2 people cannot agree. Oh. State 2 values of x for which the function is discontinuous. The best definition of continuous is the simple one, which says a function is discontinuous if you have to lift your pen off the paper to draw it. Anywhere there's a break like this, the function is discontinuous. So at 2, we have this big obvious jump where the function is discontinuous. And at 5, we have this tiny little break. It's infinitely small, but it still counts, where the function is not continuous either. So we would say this function is discontinuous at 2, and it's discontinuous at 5. Or you can say it has discontinuities at 2 and 5.